Article 310.4 of the National Electrical Code addresses requirements for parallel conductors. It's crucial that conductors of the same circuit, including grounding and bonding conductors, are not run in parallel in metal enclosures or raceways unless the length of the parallel run is 24 inches or 610 mm or less. This code requirement is in place to ensure that the conductors have the same impedance and reactance. Impedance is the total opposition that a circuit presents to alternating current, and it includes both resistance and reactance. Reactance is the opposition to alternating current due to inductance or capacitance. When conductors are run in parallel, if they are not the same length, they will have different impedances and reactances. This difference can lead to an imbalance in the current distribution among the conductors. One conductor might carry significantly more current than the others, which can cause overheating and potentially lead to a fire. So ensuring equal length helps maintain balanced current distribution and proper circuit operation. It is important to maintain the same length for all parallel conductors to prevent imbalances in current distribution. Unequal lengths introduce differing impedances, leading to uneven current sharing, potentially overloading shorter conductors. The National Electrical Code mandates this to ensure safety and reliable operation. This regulation applies specifically to conductors run in parallel within metal enclosures or raceways. The concern is that metal enclosures can exacerbate impedance imbalances if conductors are of unequal lengths. When conductors are in close proximity within a metal enclosure, electromagnetic induction can occur which can further affect impedance. It's worth clarifying what constitutes parallel conductors. Parallel conductors are two or more conductors that are intentionally connected in parallel to increase the current carrying capacity of a circuit. This is typically done when the required ampacity of the circuit exceeds the ampacity of a single conductor. The National Electrical Code provides guidelines on when and how conductors can be run in parallel. For instance, conductors must be of the same material, have the same circular mill area, and have the same insulation type. The overcurrent protection device should be sized appropriately for the ampacity of the parallel conductors. The decision made previously not to trim the cables violated the National Electrical Code. To correct it, the cables should be trimmed and reterminated to ensure compliance. Proper trimming and retermination improves the appearance and manageability of the wire bundle. This makes it easier to work with and maintain in the future. Untrimmed cables can create a cluttered and disorganized appearance which can make troubleshooting and maintenance difficult. Neatly trimmed cables are easier to trace and identify, and they reduce the risk of accidental damage. Proper cable management involves not only trimming the cables to the correct length, but also securing them properly. Cable ties, straps, and other cable management accessories can be used to bundle and support the cables. This helps to prevent the cables from becoming tangled or damaged. When reterminating the cables, it's important to use the correct termination methods and hardware. The terminals should be properly sized for the conductors and should be securely tightened. Loose or improperly terminated connections can create a fire hazard. It is also important to use the correct tools for the job, such as a torque wrench, to ensure that the terminals are tightened to the correct torque. This prevents over-tightening, which can damage the terminals. Remember that compliance with the National Electrical Code is not just a matter of following the rules. It's a matter of safety. The code is designed to protect people and property from electrical hazards. By following the code, we can help to ensure that electrical systems are safe and reliable. When dealing with parallel conductors, several key factors should be taken into consideration. Firstly, conductor size. The National Electrical Code specifies minimum conductor sizes for parallel applications. The purpose is to ensure that each conductor can safely carry its portion of the total current. Secondly, termination methods. Correct termination techniques are crucial to maintaining the integrity of the parallel connection. Terminals must be properly sized and torqued to prevent overheating and ensure reliable contact. Thirdly, ampacity darting. When multiple conductors are bundled together, their ampacity may need to be derated to account for the increased heat. The National Electrical Code provides tables and calculations for determining the appropriate derating factors. Fourthly, documentation. Detailed documentation of the parallel conductor installation is essential for future maintenance and troubleshooting. This documentation should include conductor sizes, lengths, termination methods, and ampacity dirting factors. Proper cable management significantly contributes to the longevity and reliability of electrical systems. Firstly, it enhances safety by reducing the risk of accidental contact with live conductors. Secondly, it simplifies troubleshooting, making it easier to identify and resolve issues. Thirdly, it improves aesthetics, creating a more professional and organized appearance. Fourthly, it protects conductors from physical damage, extending their lifespan. Maintaining equal length in parallel runs is important because impedance, which is the total opposition to current flow in an alternating current circuit, is affected by length. If one conductor is longer than the others, it will have a higher impedance. This imbalance in impedance can cause unequal current distribution. The shorter conductor will carry more current, potentially overloading it, while the longer conductor carries less. This uneven distribution can lead to overheating, insulation breakdown, and ultimately, a fire hazard. Unequal current distribution can also lead to voltage drops. The conductor carrying more current will experience a larger voltage drop, which can affect the performance of equipment connected to the circuit. Furthermore, impedance is not solely based on the length of the conductor. Other factors include the conductor's material, cross-sectional area, and the frequency of the alternating current. However, in parallel runs, where all other factors are nominally the same, length becomes the primary determinant of impedance differences. Ensuring equal lengths is a practical way to minimize impedance variations and maintain balanced current flow. The requirement for equal length is particularly important in metal enclosures or raceways due to electromagnetic induction. When conductors are placed within a metal enclosure, the alternating current flowing through them induces magnetic fields. These magnetic fields can create circulating currents in the metal enclosure, which in turn can affect the impedance of the conductors. If the conductors are not of equal length, these effects can be amplified, leading to even greater imbalances in current distribution. For parallel runs less than 24 inches in length, the National Electrical Code relaxes the equal length requirement. This is because over such a short distance, the impedance differences due to slight variations in length are typically negligible. However, it's still good practice to keep the conductors as close to the same length as possible, even in short parallel runs. When installing parallel conductors, several best practices should be followed. Firstly, use a cable puller to ensure that all conductors are pulled at the same time and with the same tension. This helps to minimize differences in length and stress on the conductors. Secondly, use a measuring tape to accurately measure the length of each conductor before cutting it. This ensures that all conductors are exactly the same length. Thirdly, use cable ties or straps to bundle the conductors together at regular intervals. This helps to maintain their proximity and prevent them from separating. Fourthly, use properly sized and torqued terminals to ensure a secure and reliable connection. This prevents overheating and reduces the risk of loose connections. Lastly, document the installation thoroughly, including the length of the conductors, the type of terminals used, and any other relevant information. This helps to ensure that the installation can be properly maintained and inspected in the future. Regularly inspect parallel conductor installations to ensure that they are functioning properly. Look for signs of overheating, such as discolored insulation or melted terminals. Check for loose connections and tighten them as needed. Measure the current in each conductor to ensure that it is evenly distributed. If you find any problems, correct them immediately to prevent further damage or a fire hazard. Remember, working with electricity can be dangerous. Always follow proper safety procedures and consult with a qualified electrician if you have any questions or concerns. When addressing the situation of trimming and terminating cables to comply with the National Electrical Code, it's important to consider the specific steps involved to ensure the job is done correctly and safely. Firstly, planning and preparation is key. Before starting any work, it's essential to thoroughly assess the situation. Review the National Electrical Code requirements for parallel conductors, specifically Article 310.4, to fully understand the regulations. Gather all necessary tools and materials, including cable cutters, wire strippers, crimpers, connectors, heat shrink tubing, and labeling equipment. Ensure that all tools are in good working condition and properly insulated. Secondly, safety precautions should be taken. Always de-energize the circuit before working on any electrical connections. Use a properly rated voltage tester to verify that the circuit is indeed de-energized. Wear appropriate personal protective equipment, including safety glasses and gloves. Follow lockout-tagout procedures to prevent accidental re-energization of the circuit. Thirdly, cable trimming and preparation is important. Carefully measure and cut each conductor to the same length, ensuring that there is enough length to make a proper termination. Use a wire stripper to remove the insulation from the end of each conductor, being careful not to damage the conductor itself. Inspect the exposed conductor for any signs of damage or corrosion. If any damage is found, cut back the conductor to a point where it is clean and undamaged. Fourthly, connector installation plays a role. Select the appropriate type and size of connector for the conductor size and application. Crimp or compress the connector onto the conductor using the correct tool and technique. Ensure that the connection is secure and meets the manufacturer's specifications. Use heat shrink tubing to insulate the connection and provide additional protection against corrosion and moisture. Fifthly, termination and securing should be completed. Carefully connect each conductor to its designated terminal, ensuring that the connection is tight and secure. Use a torque wrench to tighten the terminal screws to the manufacturer's specified torque. Properly support and secure the cables using cable ties, straps, or other appropriate methods. Sixthly, labeling is key. Label each conductor and terminal clearly and accurately, indicating its function and destination. Use a durable labeling system that will withstand the environmental conditions. Seventhly, inspection and testing should be done. After completing the work, thoroughly inspect all connections to ensure that they are properly made and secured. Use a multimeter to verify continuity and insulation resistance. Perform a load test to ensure that the circuit is functioning properly and that the current is evenly distributed among the parallel conductors. Remember that electrical work can be hazardous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the job. Proper execution of these steps will ensure National Electrical Code compliance, enhance safety, and improve the overall reliability of the electrical system. It's not just about meeting code requirements, it's about ensuring the safety of people and property. By taking the time to do the job right, you can help prevent electrical hazards and ensure the long-term reliability of the electrical system.